The journey begins. Secrets of the solar system. Before you lies the greatest story ever told. The birth of worlds, the rise of giants, and the mysteries that still shape our destiny. From the fiery sun to the icy edge where Pluto whispers its sorrow. This is not just science. This is the story of our home, the solar system. Mercury, messenger of the sun. Before time was measured, before telescopes pierced the heavens, Mercury was already known. Swift-moving, elusive, the messenger of gods. Named for the Roman god Mercury, the Greek Hermes. 4.5 billion years ago, gravity gathered dust and fire into worlds. Among them, Mercury was born, small, rocky, heavy in iron. Forged in the scorching inner solar system, inside Mercury lies a massive iron core, over half its radius. A thin mantle, a fragile crust. Its surface, a twin to our moon. Cratered, scarred, ancient, yet bright hollows remain. Mercury races around the sun in 88 Earth days. It rotates once every 59 Earth days. This means a sunrise to sunrise lasts 176 Earth days. Temperatures soar above 400 degrees Celsius, then plunge below minus 170 degrees Celsius. Mercury has no true atmosphere, only a thin exosphere. Yet in shadowed polar craters, there may be water ice. The ancients saw Mercury as two stars, morning and evening. Later, spacecraft revealed the truth. Mariner 10, Messenger, and Bepi Colombo each peeled back mysteries. A giant iron heart, a thin shell, an orbit of extremes. Mercury is small, but mighty in story. Forged by fire, shaped by extremes. It is a messenger of the sun, of myth, of cosmic secrets. Stay curious. Venus, Earth's hellish twin. For centuries, Venus has been a symbol of beauty, love, and mystery. To the naked eye, it shines brilliantly in the evening or morning sky, often called the evening star or the morning star. But behind its dazzling glow lies one of the most hostile worlds in our solar system: formation and comparison to Earth. Venus is often called Earth's twin. Similar in size, mass, and composition, it could have been a paradise like Earth. Scientists believe that billions of years ago, Venus may have had shallow oceans and a climate suitable for life. But something went terribly wrong: atmosphere and climate. Today, Venus is a planet of extremes. Its atmosphere is composed mostly of carbon dioxide with thick clouds of sulfuric acid. This creates a runaway greenhouse effect. The surface temperature is over 460 degrees Celsius, hotter than Mercury, even though Mercury is closer to the sun. On Venus, metal like lead would melt in seconds. Surface and volcanism. Radar mapping shows a landscape filled with vast plains, mountains, and thousands of volcanoes. Some scientists think Venus may still be volcanically active today, but no human eyes have seen this surface directly. Only spacecraft and radar instruments have revealed it to us. Rotation and strange day-night cycle. One of Venus's most bizarre traits is its rotation. Venus rotates backward, opposite most other planets, and takes 243 Earth days to complete one rotation. But its orbit around the sun takes only 225 days. This means a day on Venus is longer than its year. The future of Venus exploration. Despite its dangers, Venus remains one of the most fascinating planets. Future missions aim to explore its thick atmosphere, volcanic surface, and perhaps uncover whether it once had oceans and life. By studying Venus, we also learn what can happen to a planet very much like Earth. Venus is not just a world of fire and storms. It is a warning. a vision of what happens when a planet turns against life itself. Our twin, but one that chose a path into darkness. Earthrise, the screenplay, dark matter stories. Opening note: imagine a world of fire, chaos, and cosmic violence. A place where molten rock rained from the sky, seas boiled, and the land raged. This was not the Earth we know today, but the terrifying and magnificent birth of our planet. Act 1. A violent beginning. 4.6 billion years ago, our solar system was nothing more than a swirling cloud of dust and gas orbiting a young, blazing sun. Gravity, the invisible sculptor, had gathered this cosmic debris, shaping particles into rocks, rocks into mountains, and mountains into worlds. One of these worlds was destined to become Earth. But its beginnings were not a paradise. The newborn planet was a hellish inferno, a molten, red, glowing surface constantly bombarded by massive asteroids. Each collision could vaporize the oceans, shake the continents, and even tilt the planet's axis. And then came Theia, a planet the size of Mars. It collided with the young Earth in a cataclysm so powerful that it nearly destroyed both planets. Molten debris from this collision was hurled into space and slowly formed our moon. Act 2, from oceans of fire to oceans of water. As the chaos slowed, something extraordinary began. Volcanoes spewed steam and gas into the atmosphere. Slowly, clouds formed. Then, for the first time, a continuous rain fell for millions of years. The surface cooled. Fire gave way to water, and vast oceans spread across the planet. Earth had transformed from a world of fire into a world of water. But these oceans were not yet peaceful. They boiled with heat and energy, thrashed by storms of unimaginable power, and within them, the first seeds of life waited. Act 3. The mysterious spark. Somewhere in those ancient seas, lightning struck. Chemistry became biology. Simple molecules bonded, twisted, and tore apart, until finally, life was born. Tiny microscopic organisms thrived in the deep oceans, feeding on minerals and sunlight. Fragile, invisible, but unstoppable. These first creatures would one day shape the planet itself. By releasing oxygen into the air, they shaped the atmosphere we breathe today. They laid the foundations for forests, animals, and us. Act 4. Earth becomes a home. For billions of years, Earth moved from chaos to balance. Continents drifted like giant rafts, mountains rose and fell, and climates changed. But through it all, life adapted, evolved, and endured. From fire and stone, to oceans and air, to the living world we see today. This is the story of Earth's birth, a story written in the stars, the rocks beneath our feet, and every breath we take. Closing chorus. The Earth is 4.6 billion years old, but it's still a child on the vast timeline of the cosmos. What secrets does its past hold, and what does its future hold? Dark Matter Stories. Mars, the red time capsule. Far beyond Earth, in the cold shadows of the solar system, lies a world both familiar and alien. The red planet, Mars. Birth of Mars, 4.6 billion years ago. Mars was born from chaos. A half-formed world smaller than Earth, colder than Venus, destined to become a frozen relic of the solar system. Its core cooled too quickly. Its magnetic shield vanished, and Mars fell silent, while Earth thrived. The red mystery. Why is Mars red? For centuries, we believed it was rust. But new science reveals another story. Minerals called ferrihydrite, born in ancient waters, painted the planet crimson. Mars's color is not just rust. It is the memory of lost oceans, a silent time capsule. Today, Robots roam its surface, drilling, sampling, listening. NASA's InSight mission revealed Mars has a solid core, a mantle, and a crust, like Earth. But hidden deep inside, scientists discovered mysterious relics, fragments of failed planets trapped for billions of years. Mars is a fossil, a time capsule of the early solar system. The Whisper of Mars. Mars shows us two faces, a world once wet and alive, and now a frozen desert. Its red dust whispers across the ages, I too was once alive, I too held water, maybe even life. Closing Mars is not just a planet, it is a time capsule of cosmic history, and its story is far from over. One day, humans may walk its crimson sands. Jupiter, the giant secret heart. In the silent void beyond Mars, a giant reigns supreme. Jupiter, king of planets, forge of storms, keeper of secrets. What lies beneath those raging clouds within that tumultuous heart? Today, we journey into Jupiter's soul, 4.5 billion years ago. As the solar nebula spun and cooled, Jupiter gathered mass, mostly hydrogen and helium. It grew fast, dominating its neighborhood. Its gravity-shaped asteroids, comets, even orbits. The youngest, largest planet, more than twice the mass of all other planets combined. Jupiter has no solid ground. Its depths are layers of gas, liquid, metallic hydrogen. Recent Juno data suggests its core is not solid rock, but fuzzy, partially dissolved, blending with the metallic hydrogen around it. Deep pressures, raging heat, stress test for physics. Look up at Jupiter and you see bands of storms, white, brown, ochre. They swirl. Massive storms, jet streams, lightning, and then great red spot, an anticyclonic tempest larger than Earth, raging for at least 300 years. Its depth, its color, still partly a mystery. What compounds paint its scarlet hue? What forces feed its fury? Jupiter spins fast. One rotation takes about 9.9 hours. That's lightning speed for a planet this large. Beneath clouds, ammonia, water, storms churn. Recent studies show mush balls, softball-sized hailstones of ammonia and water, forming in thunderstorms, then falling into the depths, help explain missing ammonia at cloud tops. Jupiter is surrounded by family, moons, more moons, Io, Europa, Ganymede, Callisto, each a world of its own. Europa may hide an ocean beneath its ice. Ganymede is larger than Mercury, and then faint rings, dusty trails from minor moons. But beware, Jupiter's magnetosphere is a shield and a scourge, radiation belts deadly to spacecraft and to any casual visitor. Deep inside, the metallic hydrogen acts like a dynamo, generating one of the strongest magnetic fields in the solar system. It stretches millions of kilometers into space. Solar wind crashes into it. Charged particles dance along field lines, lighting up the poles in auroral glory far beyond Earth's modest show. But what remains unknown still dwarfs what we know. What is the true nature of its core? How deep do storms reach? Is there still interior thermal heat fueling them? Could some moons harbor life? Upcoming missions like NASA's Europa Clipper, ESA's JUICE, and other proposals aim to peel back Jupiter's layers, to see not just the face we know, but the heart. Jupiter, giant, majestic, terrifying, a planet born of chaos, a storm without equal, a companion of worlds. Its secrets are many, but one thing is sure. When we gaze at Jupiter, we see more than clouds. We see the scale of the cosmos itself. Stay curious. Saturn, the ringed giant. Imagine you are aboard a spaceship and before your eyes, a massive planet slowly comes into view, its golden rings sparkling against the cosmos. Behold, Saturn, the most elegant and mysterious giant of our solar system. Saturn is not just a planet. It's a story, a secret, a marvel of nature. And today I will take you beyond its rings, into the icy moons, and deep into the gas giant itself. Saturn, the sixth planet from the Sun, is a colossal gas giant. It has no solid surface and is composed mostly of hydrogen and helium. Its diameter is 9 times that of Earth. Its mass is 95 times Earth's. Its atmosphere is alive with storms and giant clouds. Its rapid rotation makes the equator bulge and the poles flatten, giving Saturn its iconic golden sphere appearance. The rings are Saturn's most captivating feature. Stunning, vast, yet incredibly thin, they stretch over 250,000 kilometers, but are only about 10 meters thick. Made of ice and rock fragments, each piece silently dances in orbit. Galileo first observed them in 1610, but their nature remained a mystery. In 1675, Cassini discovered the gaps and the complex structure of the rings. Imagine these enormous rings, like a silent instrument playing the music of the universe. Saturn's moons are as fascinating as the planet itself. Currently, there are over 274 of them, each with its own story. Titan, the largest moon, has a thick atmosphere and its surface hosts lakes of methane and ethane, a young version of Earth. Enceladus, a small icy moon, has jets of water vapor and organic compounds erupting from its surface, mesmerizing scientists. Perhaps one day we may find clues of life here. Each moon deepens Saturn's story, showing us the planet is not alone, but part of a cosmic family. Observing Saturn has inspired scientists for centuries. When Galileo looked in 1610, he only saw a bright disk. But detailed exploration began in 2004 with the Cassini-Huygens mission. Cassini studied Saturn's atmosphere, rings, and moons for years. The Huygens probe landed on Titan and sent back surface data. In 2017, Cassini's final dive into Saturn's atmosphere was a farewell for humanity, but also a triumph of discovery. Saturn is not just a planet, it is a teacher and a storyteller. Its rings whisper the tale of time. Its moons reveal the diversity of the cosmos. And the depths of this gas giant will always ignite human curiosity. What do you think is the secret behind Saturn's rings being so wide, yet so thin? What are your thoughts on the possibility of life on Titan? If you could travel to Saturn like Cassini, which moon would you explore first? Leave your answers in the comments, and let's explore Saturn's secrets together. Uranus, the tilted ice giant. Far beyond the warmth of the sun, there lies a world turned on its side, a planet of ice, wind, and mystery. This is Uranus, an ice giant unlike any other. Its tilt alone defies all expectation, its rings whisper of violent pasts, and its moons hide secrets in frozen darkness. What story does this sideways world tell? Part 1. Discovery and Namesake. Uranus was discovered in 1781 by William Herschel using a telescope, the first planet discovered in modern times, not known since antiquity, initially thought perhaps a comet or a star, only later recognized as a planet. Named after the Greek god of the sky, Uranus, Oranos, the predecessor of the Olympian gods. Part 2. Orbit, tilt, and rotation. Uranus is the seventh planet from the Sun, at an average distance of about 2.9 billion kilometers, approximately 19 astronomical units. Its orbital period, year, is about 84 Earth years. A single day, rotation on its axis, lasts about 17 hours. But its axis tilt is what stuns, nearly 98 degrees, meaning Uranus essentially spins on its side. Its poles take turns pointing toward the sun, causing extreme seasonal patterns. A pole in sunlight for decades, then darkness. Part 3. Structure, Composition, and Atmosphere. Uranus is an ice giant, not a gas giant, made up mostly of hydrogen and helium in its outer envelope, but a large portion of its mass is ices, water, ammonia, methane. The color you see, that blue-green glow, comes from methane absorbing red light, leaving blues and greens in the visible spectrum. It is extremely cold. Uranus has one of the coldest atmospheric minimums in the solar system. Temperatures high in its atmosphere drop to approximately 49 Kelvin, minus 224 degrees Celsius, in some areas. Part 4. Rings and Moons. Uranus has a system of 13 known rings. These rings are faint, dark, and narrow. They were imaged clearly by Voyager 2 in 1986 and followed by Hubble observations. The rings are composed mainly of dark particles, water ice mixed with darker organic compounds, possibly radiation-processed material. Uranus has 28 known moons. Recent discovery may have added small ones like S/2025U1 to bring the count to 29, many named after Shakespearean or Pope characters: Miranda, Ariel, Titania, Umbriel, Oberon, etc. Part 5. Unique Phenomena and Magnetosphere. Its magnetosphere is unusual, tilted far from the planet's rotation axis, offset from its center. The interaction with solar wind is complex. Voyager 2 data gave insights, but some earlier conclusions are being revised because that flyby happened during a rare solar wind peak which compressed Uranus's magnetosphere, meaning some earlier readings might misrepresent typical conditions. Uranus's atmosphere shows slow, subtle storms, dark cloud spots, and faint banded patterns. Because Uranus emits very little internal heat compared to other giant planets, its weather is more subdued, but its extreme seasons due to tilt make it interesting. Part 6. Formation, Theories and Mysteries. How did Uranus get such a tilt? One theory: a massive collision early in its history bumped it onto its side. Alternative or complementary theories involve interactions during formation. Some of its moons, especially the large classical ones, might harbor subsurface oceans beneath ice shells. Observations suggest they have dark, icy surfaces, possible organic coatings. But direct evidence is limited, and more missions are needed. There is very little internal heat compared to other giants, which raises questions. Why so little? How does that influence weather, atmospheric circulation, and cloud structure? Uranus is more than an odd planet. It's a whisper of what planets can become under wild tilts and frozen distances. It challenges our ideas of seasons, moons, and what a planet can be when it defies expectations. As we plan future missions, let us remember, in the far reaches of the solar system, the sideways ice giant has stories yet untold. Neptune, the wind-swept ice giant. Far at the edge of the solar system, where sunlight barely warms the air, a world dances in frigid storms and relentless winds. Blue, cold, mysterious. Neptune, the ice giant, keeper of the mightiest winds and guardian of secrets beneath its shrouded atmosphere. Part 1. Discovery and Name. Neptune was discovered in 1846 through mathematical prediction, not by casual observation. Astronomers John Couch Adams and Urbain Le Verrier calculated where a new planet should be. Johann Galle then observed it. Named after the Roman god of the sea, Neptune Poseidon in Greek mythology, appropriate for its deep blue hue. Part 2. Orbit, Rotation, and Position. Neptune is the eighth and most distant known planet in our solar system. It orbits the Sun once every approximately 165 Earth years. Its rotation period, day, is about 16 to 17 Earth hours. Because of its distance, Neptune cannot be seen with the naked eye. It appears faint through telescopes. Part 3. Composition and Atmosphere. Neptune is an ice giant, mostly hydrogen and helium in outer layers, but deep inside water, ammonia, and methane ices under very high pressures and temperatures. Its striking blue color comes from methane in its atmosphere, absorbing red wavelengths of sunlight and reflecting blues. The cloud tops are extremely cold. Temperatures can drop to approximately 55 Kelvin, approximately minus 218 degrees Celsius, in some high atmosphere regions. Part 4. Storms and Winds and Weather. Neptune has some of the strongest sustained winds in the solar system, reaching up to 2,100 kilometers per hour in some storms. Famous storms: the Great Dark Spot observed by Voyager 2 in 1989, a storm large enough to swallow Earth. The atmosphere has banded cloud layers, dark spots, clouds made of methane, and complex weather patterns despite low solar energy. Part 5. Rings and Moons. Neptune has a faint ring system, several rings and arcs of particles. These rings are dark and narrow compared to Saturn's. Moons, at least 14 to 16 known moons. The largest moon is Triton. It's unique, orbits Neptune in a retrograde direction opposite to Neptune's spin, likely captured rather than formed alongside Neptune. Triton shows geysers, nitrogen geysers, possible cryovolcanism, extremely cold surface, thin haze atmosphere. Part 6. Internal Heat and Mysteries. Interestingly, Neptune emits more energy into space than it receives from the Sun. There's internal heat, perhaps left over from formation or generated by interior processes. Questions that remain: what is the exact structure of its core? Does Neptune have an ocean under the ice that could support life? What drives its internal heat and weather dynamics so strongly at that distance? Neptune, the distant blue giant, winds unchained, storms unseen, a moon that challenges formation, and heat that refuses to dim. In the darkness beyond, Neptune stands as a reminder: even at the edge, there is fire, there is motion, there are secrets waiting. Stay with Dark Matter Stories. Keep your eyes on the skies, for the frozen giant still. Pluto, the lonely heart of the solar system. Far beyond the warmth of the sun, in the frozen darkness of the Kuiper Belt, drifts a small, lonely world. Pluto, once celebrated as the ninth planet of our solar system, today it is no longer called a planet. This is a story of discovery, of hope, and of heartbreak. In 1930, a young astronomer named Clyde Tombaugh, working at the Lowell Observatory, spotted a faint moving dot among the stars. That tiny dot would soon capture the world's imagination. Pluto was announced as the ninth planet. For decades, children memorized its name in school, scientists dreamed of exploring it, and humanity believed the solar system's family portrait was finally complete. But Pluto was always different. A frozen, distant sphere only about 2/3 the size of our moon. Its surface, made of rock and ice, is colder than nearly anywhere else in the solar system, almost minus 230 degrees Celsius. Pluto is not alone. It has 5 moons, the largest of which, Charon, is so massive that the two worlds orbit each other like a binary system, locked in an eternal dance. Then, in 2006, everything changed. The International Astronomical Union redefined what it means to be a planet. To hold the title, a world must orbit the sun, be large enough to become spherical, and clear its orbit of other objects. Pluto could not. And just like that, Pluto was demoted to a dwarf planet. For scientists, it was only a matter of classification. For the rest of us, it was heartbreak. The little world that had inspired so much wonder was stripped of its crown. Now Pluto drifts in the Kuiper Belt, surrounded by countless icy bodies, no longer a planet, no longer part of the family it once completed. And yet, in the hearts of millions, Pluto remains the 9th planet, beloved, defiant, a symbol of how fragile definitions can be and how strong imagination truly is. In 2015, a spacecraft called New Horizons brought Pluto back into the spotlight. After a 9-year journey across the solar system, it flew past Pluto. For the first time, we saw its surface in stunning detail, vast plains of frozen nitrogen, towering mountains of ice, and most famously, a heart-shaped region that seemed like Pluto's own silent message to us. I may be small, but I am not forgotten. Pluto may no longer carry the official title of planet, but in the story of the cosmos, its place is eternal. It is the lonely heart of the solar system. And sometimes, the smallest worlds carry the greatest emotions. Don't forget to like, share, and subscribe for more cosmic journeys. The sun. In the vast darkness of space, one star reigns supreme, the sun. For billions of years, it has been both the creator and the destroyer of life. The story of the sun begins 4.6 billion years ago. A giant cloud of gas and dust collapsed under its own gravity, igniting a fire that still burns today. From this blazing inferno, the planets were born. Earth itself is a child of the sun. At its core, a relentless process takes place. Nuclear fusion. Hydrogen atoms crash together, fusing into helium, releasing energy beyond imagination. Every sunrise we see on Earth is powered by this eternal fire. But the sun is not calm. Its surface boils with storms larger than Earth itself. Solar flares and coronal mass ejections hurl deadly radiation across space. Sometimes they reach us, shaking our magnetic field, disrupting satellites, and threatening power grids. The same sun that gives us life can also strike us with its wrath. Look closer, and you will see its scars, sunspots, dark magnetic storms that rise and fall in mysterious cycles. Even here on Earth, ancient civilizations recorded strange skies, not knowing the sun's restless heart was the cause. And yet, for all its fury, the sun is our protector. Its warmth keeps our oceans liquid, its light feeds our plants, and through them, us. Without the sun, Earth would be a frozen wasteland, drifting in eternal night. But one day, the sun will change. In about 5 billion years, it will swell into a red giant.
Its fire will scorch Mercury, Venus, and perhaps even Earth itself. The oceans will boil, the skies will burn, the creator of life will become its destroyer. And after this violent transformation, the sun will shrink into a white dwarf, a fading ember of what it once was, still glowing, but no longer alive. The sun is not just a star. It is the beating heart of our solar system. It is our past, our present, and our fate. The question is, how long can we dance with fire before it consumes us? Imagine a single ocean of fire so vast it holds 99.86% of everything that orbits it. Imagine a heart that has been beating steadily for 4.6 billion years, giving light, warmth, and life, but also capable of sudden, violent temper. This is our sun, a star, a furnace, and the center of our story. 4.5 billion years ago, in a cloud of dust and gas pulled inward by gravity, our sun was born. A spinning nebula collapsed, most material fell to the center, and ignited a thermonuclear engine. The same cosmic drama that made our sun made the planets, and set the stage for life on Earth. Sun's age and formation summarized from modern stellar models and NASA overviews. The sun is not a solid ball. It is a scorching sphere of plasma, mostly hydrogen and helium. In terms of mass, roughly 3/4 of that mass is hydrogen and about 1/4 helium. Heavier elements are vanishingly rare but crucial, formed in earlier generations of stars and sprinkled into the cloud that birthed our system. This composition is the reason the sun burns the way it does and why it can shine for billions at the core, under pressures and densities almost impossible to imagine. Hydrogen atoms collide and fuse into helium, the proton-proton chain that releases prodigious energy. Temperatures in the core reach around 15 million degrees Celsius, and this fusion powers everything we see: light, heat, and the solar wind. Every second, the sun converts a few million kilograms of mass into pure energy, a staggering transformation that keeps the solar system alive. Move outward and you pass through the radiative zone, then the convection zone, and finally the visible surface, the photosphere. The photosphere is cool compared to the core, about 5,500 degrees Celsius, the layer whose light warms our days. Above it lies the chromosphere, and then the corona, a tenuous outer atmosphere that mysteriously blazes at millions of degrees, far hotter than the surface beneath it. Understanding why the corona is so hot, the coronal heating problem, remains one of modern astrophysics' greatest puzzles.
The sun is not calm. Dark sunspots, magnetically charged and cooler than their surroundings, wax and wane with an approximately 11-year cycle. At cycle peaks, we see more sunspots, more flares, and more coronal mass ejections, eruptions that can march through space and disturb satellites, radios, and power grids on Earth. The current solar cycle 25 has been unusually active, and its maximum activity clustered around 2024 to 2025, a reminder that our star's moods can have earthly consequences. Beyond light, the sun blows a constant stream of charged particles, the solar wind, shaping planetary magnetospheres and carving a bubble in interstellar space called the heliosphere. Modern missions are now flying into the sun's realm to learn how the wind is born. NASA's Parker Solar Probe has skimmed closer than any human-made object, sampling the solar atmosphere and giving us unprecedented data about how particles accelerate and how the corona behaves, changing long-held ideas about the sun's outer layers. The sun is our life source, but it is also a laboratory for physics. Studying it teaches us about fusion, the same process humans hope to harness on Earth, about magnetic plasma, and about how stars age. It protects us and threatens us. It made our planet habitable, and it will someday change the destiny of Earth when, billions of years from now, it expands into a red giant. For now, though, it is our steady centerpiece, powerful, complex, and full of stories. So when you step outside and feel the sun on your face, remember, you're touching the result of cosmic events stretched across aeons. The sun is more than light. It is a living star with rhythms, tempers, and secrets we are only beginning to read. Join us as we follow those secrets from the heart of fusion to the storms of the corona, and learn why the sun remains the greatest storyteller of our sky. The sun gave us life. The cosmos holds our destiny. Be part of this story. Subscribe now, hit the like button, and share this journey, because the universe is waiting for us.